In section 4.6, we're going to be multiplying polynomials. And so what does that mean? Like in example 1, you have a binomial, 2 terms, times another binomial, another 2 terms. In example 2, you have a binomial times a trinomial. So how do we do this? When you have a quantity like a plus 2 that you need to multiply by another quantity. Well, you're going to distribute both of those terms. So this is kind of what that looks like. You're used to distributing that 2, right? That's pretty normal. Like you're used to distributing a 2 when you have just like a number in front of a parentheses. But we're also going to distribute the first term, the a, to that entire parentheses. So this is typically how I would write my steps. First, you're going to distribute that a to all of a minus 3. But then you're going to distribute the positive 2 to all of a minus 3. Because you're really needing to multiply that entire binomial times the other binomial. So when we distribute the a, we're going to get a squared minus 3a. Then when I distribute the 2, I'm going to get positive 2a minus 6. Now I would be done, except for I can simplify this. This has 4 terms, but I notice that I have 2 terms that are like terms. So I'm going to simplify that, and that's going to be a to the second. If I have a negative 3a plus 2a, that's going to be negative 1a, which I can write just as minus a. And then I have my minus 6. And this is my final answer. All right, in example 2, very similar. I'm going to multiply that whole binomial. So if I'm going to multiply the whole binomial times the trinomial, I need to distribute all of that binomial. So I'm going to start with distributing the y. And so I'm going to go ahead and write my step for a while. I'm going to distribute the y to that whole trinomial. But then notice I have a minus 2. I need to distribute that minus 2 to that whole trinomial. Well, when I write my steps out like this, then it's really not any different than what we did in the last section where you were just distributing monomials. So once you break up that polynomial into monomials that you're distributing, it's really not any different. So once I distribute the y, I have y to the third minus 2y to the second plus 3y. And then once I distribute that minus 2, that's going to give me minus 2y to the second plus 4y minus 6. Now I would be done, but I do notice there's some like terms. So I only have a y to the third, but then I have minus 2y to the second minus another 2y to the second. That's like saying I'm losing 2 yo-yos and I'm losing 2 more, so I'm losing 4 yo-yos. And then I also notice I have 3y plus 4y, so that's like saying 3 xylophones plus 4 xylophones. So I have a positive 7y, and then I'm just going to bring down that minus 6. And that's my final answer. I can't go any further because none of those are like terms. Now in example 3, this should say solve. So I'm going to go ahead and write that. Because this is an equation, so we can solve equations. We have a binomial times a binomial on the left. So I'm going to start by distributing that 3x to 2x minus 3. But then I also need to distribute that positive 5 to 2x minus 3. So I'm going to do that first. I have 6x to the second minus 9x. Now I distribute the 5. I get a 10x minus 15. Now I'm going to simplify that side before I go any further. So that gives me 6x to the second. If I combine negative 9x plus 10x. That gives me a positive x. And so there you have the left side. Now I'm going to do the same thing on the right, or very similar. I'm going to distribute the x to all of 6x plus 5. And then I need to distribute that negative 1 or minus 1 to 6x plus 5. And that's going to give me 6x to the second plus 5x. Now I'm distributing a negative 1 or a minus 1. Sorry about that. It's wanting to get bigger on me. Now on the right side, that gives me 6x to the second minus x minus 5. So I have a quadratic. And so normally with quadratics, I need to get one side equal to 0. But I do notice that when I subtract 6x squared, notice how those quadratics are going to go away, because 6x squared minus 6x squared is 0, x squared, which is just 0. So I'm really left with x minus 15 equals a negative x minus 5. Don't forget the sign that's in front of that term. Now I want to get all my x's together, so I'm going to add x to both sides. See if I can move this up a little bit. I'm gonna have to go over here. So that's going to give me 2x minus 15 equals a negative 5. Then I can add 15 because it's just a two-step equation. 2x equals 10, and so x equals 5.